So another logic sense of things. So what this one actually mean, right? It basically represent this item over here. So this one, okay, let's start off with this one. Okay, so this item 1, it is represented by this value 5. When they say 1, it's like saying that, okay, operation Z, I'm taking 1 coin from my in array. So that's what this 1 represent. So 1 represent one of the element in the in array. That's what it represents, fundamentally speaking. So this 1 represents this 5. So obviously, what plus 5 equals to 7? You need a 2, right? So 2. And then so this represents how many coin? Straight up, you know, this takes up like 1 coin, and we check this guy require how many coin? This require 2 coin. So in fact, you 1 plus 2, you get the 3. And similarly, this 1 coin of 4. 4 plus what become 7? 3. So you 3, and then here represent 1 coin. DP3, you need like 1 coin too. So in the end, you need 2 coins. 1 coin from the 3, I mean 1 coin of the 3, and 3 you need plus what to become 7? You need plus 4, so DP of 4. And DP of 4 requires how many coin? It requires 1 coin. So therefore, you 1 plus 1 equals 2 coin. This guy is like 1 coin of like 1. So this is like 1 coin obviously. And you 1, you plus what becomes 7? You plus 6. So therefore I input a 6 over here. And 6, how many coins do I need? I need 2 coins. So 1 plus 2, I get the 3. And how do I actually calculate all this, every single item? I start off with saying dp equals to 0. So this item is actually means that how many coin do I need among all this to become the value of 0. I need 0 coin to, so this is very important. Operation E. How many coins I need to reach 7. And this 7 is basically my rule book's core objective. And when you talk about like the core objective, it can usually lean towards saying operation F, or operation G that is like result dependent. Or it can be also mana cost dependent. And for this case, the core objective is very result dependent, in my opinion. It's because we are very much looking towards like the results. So how can I reach until the result 1 with given all these items? I can have like 1 coin to actually achieve that result. How can I achieve the 2 value with these coins? I need 2 of this 1, right? So I need 2 coins. So if you were to actually simplify it, it's like saying that these guys are bottom up, because here you straight away can answer the question, and most of the time at the bottom you can answer the question. That's the main idea. That's why you use bottom up. That's why you don't use top bottom. Maybe say operation O is saying that bottom up. It just means that have base value. And if you were to actually argue the opposite end of things, maybe say operation L, you start from top down. What you're gonna get? You have no base value, and if you have no base value, you can't start doing memorization. But if you start from bottom up, you have base value and you can do some memorization, and that's gonna solve like some parts of like the problem. But if you got nothing at all, you can't like conveniently solve problems. But bottom up, you have base value, you can conveniently solve values. So it's about whether you can actually at the end of the day conveniently solve some calculation that's actually happening, right? So now we zoom in over here. Obviously we finish until the 2, now is a 3. How many values is required for me to be able to solve to get to 3? I mean, from these guys we can see that we can use 1 coin. How many how can I reach until the 4? I need 1 coin. 5, I need 1 coin. 6, I need 5 and a 1, so 2 coin, right? This is definitely a different perspective, in my opinion at least. Right? And what I can say is this: I actually need to take a good look. Okay, the thing is this, that operation H is saying that like different, obviously I mean different LeetCode question, different LeetCode rulebook will have like different expectations, or rather they have like some form of like different rulebook result that they actually truly want to actually return to the system. And in other words, this item is also the what we call, maybe say, the dependent factor, right? So, and as we know that dependent factor falls under two category. So like category 1, it's say that mana cost. Category 2, it's basically the results manipulation. Sometimes is that the final result that you want, sometimes is the number of like items in the results. So we're talking about quantity, and sometimes we are talking about say the summation. Sometimes we can even say the product of the result. And for this very case is that we're looking at like the result of the summation. So the result of the summation got to be 0, and how many quantity, this is like talking about like quantity, do we need? We need 0 of it. So in fact this is our result, and this is the result summation, and this one is like the quantity that's required. I need 0 quantity to actually reach this result summation. I need 1 quantity to reach the result summation of 1. I need 2 quantity, and in this case was double 1 coin to reach the result of summation of 2. And at certain points you can use part of this base case to actually do your calculation for these areas. So maybe say for like the areas over here, maybe say DP3. I mean, let's just say what I feel like is maybe say DP3 is very much of the combination of maybe say DP2 and say DP1. And for this case we already calculate DP1 and 2. Here we need say 2 quantity. Here we say we need 1 quantity. So we have like the option of is either 3 or I'm kind of shocked to get this answer, or obviously, or I get a 1. 1 is because that my in array already has like the 3. I think at some point I can use this as an example. This is very important. If I can apply this into here, have a good picture of it, I think I can solve this. But I'm just looking forward, like at least this thing for the first time is actually starting to actually make sense, and I'm just looking forward towards how can I implement this logic into finding out the bigger concept of things. Looking forward. I think comes to an end.